G'day guys, let's make sure this is on. It is. Yeah, just been working on a couple of GPZ 7000s and yeah, just a couple of interesting things. One had a blown up power supply. I've had this before, a little linear technology power supply, the inverting power supply. Yeah, dead, and one of the rails drops out, so what a job to replace it. My God, you got to heat the whole board up and then work on it with a very, very low melting point solder and get it all to go on the board and hopefully stay there. You won't be able to use normal solder. I think when they do these boards, they do it through an oven, but they don't put the electrolytic capacitors on. They do that last. That's my assumption. Thus, you can heat the board up. If I heated the board up how hot it needed to get to be able to put solder on the board, all the electrodes would have exploded, right? So, yeah, basically, here's another one that I was working on, and I've just got some test, using resistor legs as test points, but all these electrolytic capacitors, if you put them at the temperature that you've got to get the board at to heat and replace a little chip there at the tip of my finger, it's very, very difficult. It's definitely a machine job. It's not meant to be done by hand, but what do you do? If the detector blows up, what do? Throw it in the bin? No. Fix it. So yeah, there's a fairly a lot to these detectors. But that one there, that one's fixed, and that's going back in the box, and this one's just been fixed and is going back in the box. But one thing I did find, this might interest you fellows who like fiddling, right? On the board, there's these plastic clips there, and basically it routes the receive line here, that's the receive line, to the infamous black module. That it holds it very close to the board, which, yeah, it's what you do normally, right? And it routes it through here, and it goes down there anyway. It goes past the power devices for the transmitter, and it's all down there. What I've done with these, I've taken the cable off and I've floated the cable in the air like so, and I've also used three clips, one there, and one there, and I've routed it on the other side of the capacitor. Now you'd think that because there's a high-powered 5-volt switch mode here and a negative switch mode there, that's closer to the cable and it would couple and possibly introduce noise. Well, it actually doesn't. The noise in the detector actually decreases if you reroute that there. I don't know. I've never done a field test with it like that. I just did it on the workshop bench, and I could actually perceive a drop in noise. So that might be one thing to play with. All you got to do is basically flip that from there to there, like so. It's all it's got to do is go around there, and yeah. Or the other thing is just have it away from the board. Just for some reason, there's just less coupling. I don't think the shielding's very good on this cable. I don't know. I haven't stripped it back and looked at it, but maybe it's a very light shield, and you know, little wiggles get in and upset the receiver. I don't know. I could waste a lot of time stripping it all back and doing some tests, but I've got work to do. But I thought I'd just make that small video just to show that just by flipping that there to there can get rid of some of the noise. So I've got this thing running in on the bench. I've got it on a gain of 1. I've got it on a coil. I've changed the phase on it so it acts as a cancel coil to a degree. Otherwise, it would just be going completely bonkers in here. So yeah, that's how you work on these. You get an old coil, you rip it apart, you change, you just phase change the receive windings, and yeah, it sort of quietens it right down. Interesting. But I wouldn't go detecting like that because I don't think it will ground balance properly. I mean, it works. It picks up targets fine. I mean, like, you know. Yep, no worries picking up targets, even on a gain of 1. So that's the story with these things. Let's put the sensitivity up. I'll just see how what we can get away with. Yeah, sensitivity of 10. Yeah, it's all right. It's quite funny raising the sensitivity with the way that's configured doesn't actually raise the noise. But oh no, let's take it. I want to try an experiment here. Yeah, gain of 20 should go completely bonkers. Yeah, it has increased the noise because a gain of 20 to a gain of 1, but it's not that much increase overall. So I'd expect it if you did that with a one of the GPX series or a GP, it'd be going 50 times worse than that. I'll just drop it all the way back down. Come on. There we go. Well, put a gain of 2. There we go. Gain of 2. Yeah, it is a lot quieter, but the overall noise isn't like 10 times or something like that. Picks up just as well on a gain of 2 as a gain of flat out. So they're definitely getting hammered by all the electrical interference getting into it. So yeah, you can see got to run that's the coil there. That hasn't even got a Faraday shield on that, so can't put your hand near it or anything like that. It's going to use a piece of wood with bits of these little test targets on it. So be aware that because I changed the configuration, I just leave it open. Yeah, so there you go. So there we go. Three 7,000 repairs in 2 days. So I don't know if that's an omen that they're all going to start coming through the door or something like that. But I don't know. Could be. They seem to be sort of very similar faults. I had one a little while ago that had a power supply problem exactly the same. There was basically no negative 5-volt rail, and found out what that is, so fixed that, and had to do the same here. But it's very difficult, very very hard to fix. I don't know if anyone really does fix them. I think with the surface mount component, I'll do a close up. I'll show you how small it is. Was this one was a different fault, but I'll move it right in, and I'll get something, a piece of wood, of course. I'll show you what blows up. It's not that there. That's a transformer, this thing. Well, it's a double inductor. It's not really a... yes, it's a transformer. It could be a one-to-one transformer, but it's actually a double inductor transformer. You can call it either. It's both. But the chip, is that there? See that little thing there? A little black thing? It's got legs underneath it. Um, so it's got to be heated up, and the board heated up and solder melted, and it perfectly put down in that position. So that's what happened to the other one. And this is perfectly fine. This one didn't blow up. The other one did. So I just put a couple of tails in there to just check the waveform and levels. Basically, I just tacked the resistor leg onto ground, and on the output of the power supply there, just to compare it to this one, just make sure it was all okay. So fix one, use the fix one to fix the other one. So all good fun. Anyway, I'm going to go and do a run. But yeah, the routing thing of the receive input wire is something you could play around with. If you're up to it, you set it up like this. You've got to split the ferrite core holder. Just cut the cable ties on it so you can run this cable up to the head unit and run the other one. I've got it because it's on this coil. It's sitting on a dongle, which is, can't see it. It's on the dongle there. So there you go. And I've got to go, don't I? Yes. Okay. So we'll call it quits and catches.